My name is Leo Leung. I'm a Senior Director of Product Management for Oracle Cloud Infrastructure. For those that I've talked to before, really good to see you virtually. For those that I haven't, I'll be on the Twitter stream, not during my presentation, but happy to answer questions there or live. All right, so I'm going to do a bit of an overview of Oracle Cloud Infrastructure because my assumption is a lot of people still don't know all the things we do, as well as a bit of an update. All right, so before we get started, please read the following disclosure statement. And I'll give you a few minutes to do that. Just kidding. The first thing actually our Chief Marketing Officer did when he joined is actually remove the whole need for a safe harbor statement and all that. So I'm going to say a bunch of stuff. Hopefully it won't get me in trouble. So I actually joined Oracle in 2016, like a bunch of product managers and engineers, because we actually saw a lot of potential to build something new, as well as take a bunch of pieces of technology and actually build a platform. So I was thinking about this today, and we really started out as a bunch of different things, right? We had software as a service, we had certain database services, we had security services, but we really didn't have a platform. And the best analogy I had was Voltron. We had a bunch of lions running around, but it wasn't super coordinated and we couldn't form into Voltron. So that's sort of what we proceeded to do starting in 2016. So that black area, the infrastructure piece, obviously we felt was the glue. We needed to work on that platform. We needed to build it from scratch and then bring the pieces together. So humbly, we started out in 2016 with a single region in Phoenix. And we've made a lot of progress since that point in 2016. And the core focus of what we built, again, very infrastructure focused, and it has a bit to do with the title of this presentation, is that we felt like there was a lot of opportunity to innovate in the infrastructure. And if we got the infrastructure right, it would actually be way easier to build the services on top. We also felt like there were some things we can do in the infrastructure layer to make it easier for customers to actually move all of their workloads to our cloud, not just the ones that were written natively for the cloud, but also the large 80% mass of their applications that were never written for the cloud. They were only written for their own data centers. So we started by building a virtual network on top of a large-scale flat physical network. And we focused on getting our compute and storage services, getting them right. So we actually started with bare metal. We started with off-box virtualization to make sure that we were able to provision entire servers as well as the virtual machines on top. And we started with pretty big, beefy boxes to have maximum amount of performance, IOPS, et cetera. Same thing with storage. A lot of focus on making sure that we had, a single type of block storage that can handle lots of different types of workloads, which you can build on top of, build file systems, build, et cetera, on top of, and making sure the connection between these resources were essentially dedicated. So every customer that comes in the door can provision an infrastructure that they can be assured of really good performance. One of the things I'll highlight here is that when we built the block storage, and I'll flip over to our console, we felt like, again, there was an opportunity to build really good block storage, essentially try to build a storage area network in the cloud, and add the kind of flexibility that we thought customers would really appreciate. So here I'm making a block volume, and just by selecting this custom option or provisioning it by API, I can not only change the capacity, but I can change the performance tier, right? So you see on the right, single block volume, I can do at a provision time, I could do it online, a lot of flexibility in the storage layer, and we're only going to add additional layers to the storage to increase the performance and give more granularity when it comes to what we call flexible storage. So some opportunity for innovation there. Second thing we said pretty simply is, can we build it so that it's actually really affordable? And maybe even raise some eyebrows in terms of how much a cloud should actually cost. So if you look very simply across a range of compute, storage, and networking, we come in much less expensive than other cloud providers, especially when you're thinking about networking and high performance types of workloads. So when you get into, as I showed you, high performance block storage, whether it's by itself or behind a database, much lower, as much as 80 or 90% lower when it comes to the high performance areas. And then bandwidth is a huge challenge for a lot of customers these days, whether they're doing things like video streaming, like the platform we're on right now, or if they're just moving data back and forth between their own data center or other clouds. Outbound bandwidth can be very, very expensive. So again, there's no actual reason why that is. Network provider underneath the covers is the same price, whether it's inbound or outbound. We make it really, really inexpensive to push data out of the cloud, as well as at no cost to move data into the cloud. Even when you look at private line networks, others call it direct connect or express route, very, very expensive. They charge you for all the data that's moving back and forth. We have a flat rate based on the port. So, so have good infrastructure, have a price that's reasonable is sort of the thinking there. And a lot of the workloads we initially brought on the platform are what you probably wouldn't do as a startup, go after the hardest workloads, right? So a lot of these big ERPs, big customer relationship management or human capital management types of applications, we've moved thousands of those into our cloud. Customers like State of Texas running, their entire payroll on OCI. So fast forward a few years, again, we started with one, we started quickly ramping and building footprint. So we started in North America. By the end of 2019, we had at least some presence in most of the major geographies to start serving customers. Obviously, we have a huge install base, so a lot of customers out of that. But that's when we started really kind of breaking out of the Oracle install base and getting into new customer types. So again, if you imagine the stack and we're building up the stack, we did a couple of other things. We added different types of CPUs to the mix, including AMD and NVIDIA GPUs. We spent more time in the virtualization layer to introduce something we call flexible compute. And then we did some cool backplane stuff. So we have RDMA as a service. So RDMA over Ethernet, where you can cluster a bunch of either compute nodes or GPU nodes and create this super low latency, high scale cluster for a variety of applications. So same kind of deal as block storage. On the compute side, if I create an instance, I also have the option of doing a flexible shape. So I could change the shape. Currently, we have it available for AMD, very soon for Intel. I can allocate exactly how many CPUs I want and corresponding RAM very, very precisely, right? All the way up to a terabyte and 64 cores. Again, we're going to roll that out across all of our different types of compute and really give that flexibility to precisely map to what the customer needs in terms of capacity. When you think about using, for example, that bare metal HPC and using that RDMA network, we're able to serve some new use cases. So Nissan's been a customer for a couple of years now, where they actually run high-scale, high-performance computing on us to do product design as well as crash simulations. Not something that Oracle is necessarily known for, but our cloud is fully capable of supporting that type of workload. And I'm really interested in seeing what else people will build on top of this type of infrastructure. So a little bit back on costs. So, I just did a quick monthly estimate of, a basic compute shape and a little bit of block storage. And one of the things we also do is we make the price consistent worldwide. So if you look around the world, it gets more and more expensive depending on where you are, right? So if you're in South America, or if you're in Australia, or if you're in Asia, the other cloud providers jack up the prices in every category. And again, there's really no reason to do that. A server is a server, no matter where it is in the world. The only place where there is some underlying differences in cost is in network providers. So it is true that we have different pricing in 3 different regions for networking. But again, we basically add a little bit of margin on top, and the cost is still dramatically less than other cloud providers. So you can really run very efficiently in our cloud and save some money. Pretty good example of that is Zoom. Certainly a really, really cool use case. I really enjoy working with them. If you didn't know, behind the scenes, what they run is actually a split architecture. They have a control plane that basically you hit when a conference is created, you're identified, you're tied to a conference, and then they point you at a bunch of media servers that actually do the heavy lifting of pushing the video and audio. And that's the part that we actually run. So they had a bunch of that. They still have a bunch of it in essentially their own data centers, because again, that's heavy network, ton of compute to be able to do that kind of workload. We were able to meet their requirements, shift a bunch of that out of their individual data centers into the cloud as they scaled through this pandemic, and we continue to scale with them. The amount of petabytes they're transferring over our networks is multiple times what's listed on this slide. Finally, in terms of our services and our cost profile, again, when you start to do the math in terms of, okay, once you get past the basic services you're running, and you want to have Kubernetes cluster management, or you want to start to add more security inspection, keep more than a month of logs in terms of your infrastructure, every single thing is charged in other clouds. And we've chosen not to charge for those things. We want it to be easy for a customer to be able to build a really secure environment, keep more logs, right? So they have more historical access to their information. And why is there a charge for cluster management? There's actually no reason to do that. So trying to make it simple for customers.
Question there on the cluster management. I know that Google changed their policy on cluster management because of CRDs, putting a lot of pressure on their management layer. And so is that something that's allowed with your Kubernetes?
Can you define CRDs?
The custom resource definitions.
Okay. It hasn't come up to date. So yeah, it hasn't come up. We don't charge for management, and we haven't changed our policies there. So okay, so happy to kind of dig into that a little bit more, Jamie. In terms of security, what we find a lot is that people, again, are cautious about how deeply they implement security, or there's only a set of people that have visibility into their security dashboards because of the extra charges that typically come with that. So being able to sort of spread the information more has been a benefit for some of our customers. I showed you the flexible infrastructure piece. Our goal is actually to get to a place where all of it is flexible, right? So we're sort of in the middle right now where you can flexibly provision storage and adjust it. You can flexibly provision compute. Our databases have this type of vertical auto scaling enabled. But pretty soon, actually this year, we'll get to a place where all of it can be tuned very granularly, as well as be adjusted online. Our compute currently can't be adjusted online yet, but that's one of the next big steps for us. And I think the biggest value here is, really giving people the value out of the cloud, where instead of having to rewrite for microservices, they can just put their application on the infrastructure and get this kind of capability. Phoenix is a customer that uses this pretty actively. They're behind the scenes in a lot of this kind of live streaming of sports, gaming, events, that type of stuff. And they're able to precisely provision the exact amount of compute they need per event, and and then scale as needed during the event. Pretty cool use case. Okay, so that's the infrastructure, and again, over the past few years, we've built a lot of services on top. So we didn't come out originally with containers and Kubernetes. We've had that for about 3 years now. We didn't have a Spark-based, big data service until a couple years ago. We have that now. A bunch of different database services. Been constantly working on our Oracle database, of course, but also MySQL. So we have a really powerful MySQL service that has analytics capability actually built in. So that's something pretty unique. And then tons of adoption of open source. So some of my peers are going to talk about our use of Terraform and how it's a first-class service within OCI. And that is our automation platform of choice. It drives a lot of the other functionality in our stack. And then, really working to try to embrace either industry standards or open standards around things like the way our events are captured and stored, our log formatting, being able to support Kafka connectors, to be able to really easily connect in and connect out of our cloud, are some things we've done over the past few years. We'll talk a lot more about VMware specifically, but we think because of the work we've done under the covers, we think we've been able to provide a really strong solution there as well. One thing I'll highlight on the data management side is, again, really thinking about it as a broad portfolio. Everybody, of course, knows we have Oracle Database, and we have a number of services that offer that, including the autonomous service, which, again, is meant to be completely hands-off, completely self-tuning. But as well, having the ability to support Spark, having the ability to support streaming into our data platform, and then being able to do the types of transformations necessary to get it into the applications you need, whether it's our own data science platforms and machine learning, training types of capabilities, our business analytics platform, or third parties, right? It's a big focus actually to make sure that the platform is really open and able to support not just Oracle technologies, but anything that's out there. One pretty cool thing that we introduced last year is the latest generation of Exadata as a service. And for those infrastructure geeks, right, this is kind of, will probably make a lot of sense. Having the ability to decouple and independently scale front ends and back ends is something pretty cool about this infrastructure, where you can get tons and tons of database processing power, or tons and tons of data storage, or a mix of either, right? Based on your needs. So, if you look at the kinds of scaling attributes, you can get to massive scale for a single large database, or obviously virtualize a whole bunch of databases into one infrastructure and simplify your management. So lots of flexibility there, and a huge amount of horsepower for either relational databases or the many other types of data that Oracle Database can support. And Todd will talk a little bit more about how we think about being able to support a lot of different use cases using a single database. National Grid's a really good example of kind of using a variety of data management services on OCI. So they use the database for a lot of their back office functions, but they also use our GPUs to do machine learning, so they can optimize how much oil or other types of carbon-based energy they need to consume and buy versus the green energy that they're producing. So this is a constant like optimization they're doing to try to get to a carbon-free state at some point. So again, not something you necessarily would think of Oracle being able to do, but more and more of our customers are, again, using the whole footprint. Tiny bit about security. So obviously we want security throughout, through all these layers, from the base layer up into the individual tenants and services. A little bit about that, and Lionel's going to talk a little bit more about it, where we definitely built the infrastructure itself to be very, very secure, completely isolated from other tenants as well as us, and completely wiped using custom silicon and a golden image of firmware before any tenant gets our infrastructure, and then really trying to automate a lot more things, whether it's making it really simple to provision a highly secure logical environment by just setting a whole bunch of best practices, or just scanning existing environments to understand, whether there's buckets that are public or if there's suspicious behavior in terms of access. All that type of stuff has been built into OCI and continues to improve. So security zones and CloudGuard are two things we introduced last year. Tons and tons of standards. One of the interesting things here is that it'd be interesting to get your take on it. There's just more and more individual country regulations around data sovereignty and data privacy. And our belief is you can build a very large public cloud footprint, but you're going to have to satisfy more and more individual countries that want to keep their data inside of their own country and where it can't leave. So the kind of footprint you're going to see, our belief is that, yes, you're going to have a very large public cloud footprint, but you're also going to have a whole bunch of these specific infrastructures in specific countries, maybe even down to a specific tenant like a government. So it feels like the regulations are going in that direction, and we're trying to match that sort of trend. Lastly, kind of again building up from the bottom, this is where really in the last couple of years we felt like we had a complete enough platform to actually go and then migrate all of those software as a service platforms we have, several dozen of them, onto the same infrastructure in the same regions. As well, we had some independent data centers, independent regions running our analytics services. Those have all been migrated and moved into the same region where our infrastructure is running. So customers are taking advantage of that as well, where, because everybody has a different pace of transition. 7-Eleven has a bunch of software as a service for things like human capital management and CRM, but their core ERP, they were probably never going to move to software as a service, or is going to take a long time, many, many years. So moving that application itself was the right move for them, and then integrating it into their software as a service. So we're able to do that for them on a single platform. So again, that migration, if you go to today, now we're at 29 regions, a bunch of different government regions in the US and the UK, as well as significant interconnection sites with Microsoft Azure, which has been a really, really good partnership where we've been able to help a lot of customers move workloads that span the two clouds or require low latency communication between Microsoft and Oracle.
Hey, Leo, I have a question about the regions.
Sure.
What makes up the establishment of a region? Do you have a minimum number of availability zones, a minimum footprint size, minimum number of interconnects? I'm just curious what defines a region in this case.
Sure. Thanks, Ned. So a region for us is typically at least one data center, which has at least 3 fault domains. So fault domains are basically resiliency within the rack, right? So that you can round robin, provision, let's say 3 or more VMs and ensure that they're not going to be in the same row of an availability domain. Some of our regions have more than one availability domain. So specifically Ashburn, Phoenix, Frankfurt, and London, London East, London 1, have 3 availability domains, which give you data center level resiliency, right? So they have additional data centers where you can span them, and they're very, very low latency between them. All these regions are connected by an Oracle managed backbone. So there's a private network that connects all of them. And we have something I'll talk about in a second called dedicated region, which is where we essentially build a region for an individual customer. And we have a few of those that we've done over the past year, where that's also connected to the backbone if they want to use any of the public services, but it's single tenant. It has all of the services in all of our regions, but it's dedicated to one customer. One of the things we do, Ned, is we have a standard set of services that we launch in every region. So we try to ensure consistency of services. We have about close to 70 cloud services available overall, and we try to ensure consistency of availability of all those services in every region.
Did you just say that you build a dedicated data center, a region for a customer? So like a colo or something like that, or can you elaborate on that a little bit more?
Yeah, absolutely. So specifically what we do is it's, I think all of you have been in the industry for long enough that we've been playing this game for a long time, right? What's a private cloud? What's a hybrid cloud? And there's been a lot of different variations and gradations of that, right? Where we ended up is, because we've gone through multiple iterations as well, where we ended up was what we call dedicated region, right? Where we take our entire control plane, right? All of our services, as well as, the actual customer resources. We take all of that hardware, we deploy it into the customer data center, right? So that's this like little red area. I wish I had the other picture of it. So all of that is managed by Oracle, right? We manage the hardware, we manage the services deployed into the customer data center. So they have full data sovereignty. It's physically there. And our only connectivity into it is to push patches, push new services, and do the sufficient monitoring in order for us to preserve our SLA, because our SLA is actually exactly the same as it is in the public cloud. So again, it probably would take more than 2 seconds, but the goal is to try to give a customer all the services, give them control over the environment, meaning the control plane, so that if it's disconnected for whatever reason, they don't lose services, right? They continue to control all of that. All the metadata stays in their premise, in their control, so we don't see any of it. Yet we still offer them services. We actually still manage the hardware. Over time, if their workload needs change, we treat it just like one of our own data centers, and we go provision the right infrastructure to support that need. Let's say they are a massive HPC shop and they need a ton of GPUs. Cool. We'll make sure that we have a plan to stage and grow the physical hardware of the environment so they can actually go run their services. So we believe it's pretty unique, and it's gotten a lot of good response.
Cool, thank you.
So very quickly, again, like a big focus on making sure a lot of services are available, including software as a service, including things like we have software as a service for clinical trials. So a lot of the clinical trials of medications that have been out there actually run on our cloud, but as software as a service, not as infrastructure, right? Very unique, I would say, in the industry. We will continue to expand the interconnect with Azure. We are trying to get a couple regions in every country. so that, again, we can preserve the data sovereignty, even in a DR type of situation where all the data stays in a country. And again, you're starting to see a lot of different models of how we're going to support tenancy, single tenancy, multi-tenant, or limited tenancy, for example, for federal agencies or governments. NRI is a really good example of this. There are very, very large consultancy in Japan that actually their software backends a lot of the financial systems in Japan, and they wanted their own region in Japan under their control in their data center, right? Even though we have 2 regions in Japan, they wanted their own. So we did that for them, and they're growing that footprint quite a bit. So to close out, it's for anyone that's worked at a startup and tried to build something, it's been 4 years of that. Maybe we're not quite Voltron yet, but we've got a lot of services and we've integrated a lot of different components into the same stack. And if you haven't given it a try, I would really encourage you to do it. Hopefully some of my peers will show you some stuff that will make you interested in checking us out and certainly beat us up and see how it goes.
One quick question.
Sure.
You mentioned in your presentation, when costing was being discussed, a lot of those charges that you've not introduced or making it like slightly cheaper for. So the other cloud providers say availability zone charges and all those kind of things that you've eliminated. Is there, have you seen a cloud adoption or people coming to you or customers coming to you just for that reason and mentioning that, yeah, this is why we've actually come to you? Or was their pricing not one of the things that they benefit from?
Yeah, I mean, I think it's certainly eye-opening for some folks. And, we know we have a reputation, right? And a lot of us, hopefully you don't blame us for being at Oracle, but a lot of us we're still relatively new. And we are trying to change perception, and it's still profitable, right? So it's eye-opening for some. Some of them, it just makes it easier for them to take that next step, because believe it or not, there's a lot of customers that are still pretty low in terms of their cloud adoption, right? And if you're going to be able to give them a TCO savings of 30 to 50 or more %, it definitely greases the wheels. I have had a lot of customers literally say, with the pricing, like, is there a decimal point off or something, right? It's confusing. How could it be, an eighth of a cent, right? For like bandwidth. And the answer is, it is that low cost, right? So hopefully that answers your question, Arthur.
Yeah, and one other thing that I remember from a few years ago, that networking, and briefly you touched upon that, having strength of networking and bandwidth that can be provided at larger scale was one of the major benefits of being on the cloud environment. Is there something coming up that I should wait for that delves deeper into that, or was that it, or will you cover it somewhere else?
I mean, we're going to talk a little bit about the networking behind our VMware offering, but no, we're not going to talk too much more about bandwidth. I mean, it's pretty straightforward, actually, where, again, our belief is there's actually no reason to charge more for outbound. There's no actual reason, technically, so we don't. And then, if you're pushing a lot of data, the savings compound dramatically, right? So if you can imagine a Zoom or an 8x8 or a Phoenix pushing petabytes a day, there's massive cost difference, right? So it is pretty straightforward. We're not going to get into it too much, but happy to answer questions further on Twitter. So.
All right. Okay. Cool. Thank you.